these differentiation problem-solving grids could be used to recap calculus at the end of year 12. Equally though, they might be used to introduce the fundamental theorem of calculus, and they're a way to encourage students to investigate antiderivatives before formalising the idea of integration as the reverse to differentiation. The first two questions don't involve a high level of challenge. We just differentiate once and twice and substitute an x value in. Question 3, however, offers something a little bit different. Here we're given an expression for the derivative f prime of x, and we're looking to find f of x when x is equal to 2. We can calculate the missing value in the bottom right corner of our grid by simply substituting x equals 3 into the expression 4x plus 8. And this is where it gets a little bit more challenging. We need to figure out a way to work backwards, and if students haven't established that integration is the reverse process to differentiation at this point, they'll really need to think about where this is going to come from. They might spot that the opposite to differentiating an expression would be to simply add 1 to the power and then divide by that new value. So we would get 4x squared divided by 2 plus 8x. Then they might notice that substituting x equals 3 into this expression doesn't give us 39. And so they'll need to realise that we need to include a constant value to make this expression make sense. Continuing through this activity sheet, and they'll then need to form and solve simultaneous equations and even consider what the third derivative of a function might look like.